So, today we'll be going to discuss a question that is listed over here. A steel wire ABC that is shown here is 16 meter long and has a cross-sectional area of 4 millimeter square, and it weighs about 20 newton as shown in the figure. With the modulus of elasticity for the given wire material is 200 gigapascals, find the deflection at the points C and point B. Now, as we have been given the total length of the wire and the total weight of the wire material, plus we also know the cross-sectional area of the wire, the material does possess a modulus of elasticity that is equal to 200 gigapascals, that is equal to 200 into 10 raised to 3 megapascals, and Pascal is a unit of elasticity, rather it is a unit of stress, and it's written how it is written as Newton per millimeter square. Now let's discuss what we have been given in this question. We have the total length of the wire equal to 16 meters. That is equal to 16 into 10 raised power 3 millimeters. After that, we have the cross-sectional area equal to 4 millimeters square. The weight of the wire material is 20 newton. It is the total weight of the wire. That is the total weight of the length 16 meter of this material. We have been given that is equal to 20 newtons. Also, the modulus of elasticity, that is equal to 200 gigapascals, that can however be written as 200 into 10 raised to 3 megapascals. Now we are supposed to find the deflection at points C and B. First of all, let's move to the point C. So deflection at point C. It is known to us that the deflection due to the self weight of a material delta L is equal to W into L divided by 2AE, where W is the total weight and not the specific weight or the unit weight. L is the length that is under consideration. E is the modulus of elasticity. A is the cross-sectional area, and 2 as there is a constant entity. Now, if we substitute the values of W, L, A and E in the above expression, we'll be having delta L is equal to 20 into 16 into 10 raised power 3, so as to convert it into millimeters, and then we have 2 into A, where that the A is the cross-sectional area and it is equal to 4 millimeters square, and there is no need to convert it into any other entity. And then we have E, that is the modulus of elasticity, that is equal to 200 into 10 raised power 3 Newton per millimeter square, since we have the megapascal equal to Newton per millimeter square. Pascal is having a unit of Newton per meter square, and megapascal is, I guess, Newton by millimeter square. So now if we solve this, it will be equal to, since we are determining the deflection at C, so here the total length will be 8 plus 8, that is 16, and the total weight will be 20 as is given in the question above. Now we have 20 into 16 into 10 raised to power 3 divided by 2 into 4 into 200 into 10 raised power 3. The 2 will go. Then solving this, we will be having a value of 0.2 millimeters. So the overall deflection of the wire, considering its total length equal to 16 meters, we will be having a deflection of 0.2 millimeters due to the self weight of the wire. After that, if we find the deflection at point B, using the same expression as we used above, delta L will be equal to WL by 2AE. But here it is worth noting that the W will reduce to half of its original value, since point B is somewhere in between A and C. If we have a total weight of the wire as 20, then half of its weight will be from A to B, if we assume that the weight is uniformly distributed along the entire length of the wire. So we'll be having W dash rather and L dash rather. W dash will be equal to W by 2, that is equal to 20 by 2, which is equal to 10 newtons. And then we'll be having L dash, that will be equal to L by 2, that is equal to 16 by 2, and that is equal to 8 meters. That is in turn equal to 8 into 10 raised power 3 millimeters, since we are supposed to get the answer in millimeters only. And hence we will be having delta L at B, that will be equal to 10 into 8 into 10 raised power 3 divided by 2 into area of cross section will be same in both the cases, that is equal to 4 millimeters square. And then we'll be having modulus of elasticity, that is also same in both of the cases, that is equal to 200 into 10 raised power 3 megapascals. After we solve this, delta L will be equal to 0.05 millimeter. So if we have to find the deflection at B, we'll be assuming that the wire is only from A to B and the rest of the portion will not be considered in the calculation, and then weight will get reduced to half of its value and length will get reduced to half of its value. But for the case of the total length, we'll be taking the entire length of the wire, that is equal to 16 meters, and the total weight W, that is equal to 20 newtons. That's all for today. Thank you.